this session, the editing tutorial, we are learning is made very simple. And in today's video, we're going to continue on our concept of trigonometry. We have one of our recent videos which was earlier released on the first concept, which we talked about the definition of trigonometry and also the foundation, the concept of SOHCAHTOA, which is very important because it lays the foundation on understanding trigonometry. So if you are watching this video currently, I will encourage you to go check out that video. Yeah, if you watch that video and you're currently watching this one, I believe you now understand the concept of SOHCAHTOA. Now, I'm going to be showing you the shortcut tricks that will help you and save you in exam. Now, the first one we are going to look at, before we start solving that question, we are going to look at sine squared theta plus cos squared theta is equal to 1. Now, sine squared theta plus cos squared theta is equal to 1. And why is this very important? This is very important because it helps you ascertain your trig value. Now, most of you will ask, how is it possible that sine squared theta and cos squared theta is 1? Don't worry, I'm going to be showing you how we came about that. Now, I want you to follow closely. Now, if we have that our opposites, is A, let's represent our opposite to alphabet A. We have our adjacent equal to B, and hypotenuse equal to C. We are going to see that using the law of Pythagoras, we have that A squared plus B squared is equal to C squared, because our hypotenuse is equal to the sum of our opposite square plus our adjacent square. So we have A squared plus B squared is equal to C squared. So C squared. Now what are we going to do next? We are going to now divide each item by C squared. So we divide each item by C squared, here divided by C squared, divided by C squared, and divided by C squared. Now why are we dividing by C squared? Don't forget your C is the longest side in your right triangle, which is the hypotenuse, and it also connects the other two sides of the right triangle, which is your opposite and your adjacent. So we are going to be dividing by C squared. So we'll have that this is, don't forget you have this is A squared divided by C squared, which is the same thing as A over C all squared. This square covers for both the numerator and the denominator, plus your B over C all squared. Now C squared divided by C squared gives us 1. Now, don't forget that your A, the value of your A is your opposite, and your C is your hypotenuse. Now let's go back to our SOHCAHTOA. So we have that our A is our opposite and our C is hypotenuse. Opposite over hypotenuse, which is our sine. Don't forget you have your square, your sine squared theta. Your plus sign, and then our B is our adjacent and C is hypotenuse. So what represents that adjacent over hypotenuse, which is our cos. Cos, don't forget your square, theta, which gives us 1. So therefore, sine squared theta plus cos squared theta gives us 1. And like I said earlier, why is this important? It's important because it helps us to ascertain our trig value. And also the next trick or the shortcut I'm going to be showing you, which will also help and save you when you're writing external exams like JAMB Maths, is the second one we have tan theta is equal to sine theta divided by cos theta. So it's possible to ascertain tan theta as a result of sine theta divided by cos theta. Now, how can we prove that? Now, we know that what is our sine theta? Sine theta is opposite over hypotenuse. Opposite over hypotenuse. Right? And our cos theta, which is scar, is adjacent over hypotenuse. So this is for our cos theta. Now we have, let's evaluate. This is opposite over hypotenuse divided by adjacent over hypotenuse. Same thing that I've done here. Now we want to divide. When dividing fraction, we can change this our division sign to multiplication. But once we change our division sign to multiplication, something happens. The denominator becomes the numerator and the numerator becomes the denominator, so they change position. So we have this to be opposite over hypotenuse. Now we change from division to multiplication, and this goes up hypotenuse over adjacent. Hypotenuse over adjacent. Okay, these are adjacent. Okay, now you can see that what our hypotenuse, we cancel out our hypotenuse, and then we'll be left with what? Opposite over adjacent. Now, if we refer to our SOHCAHTOA, what is our TOA which represents tangent? It is what? Opposite over adjacent. So see that tan theta is opposite over adjacent. So your sine theta divided by cos theta gives us our sine theta. Now let's go to the questions that we have on the board. Now we have question 1. If sine theta equals 5 over 15, find cos theta. Now we are going to be solving this using this trig identity. So we have if sine theta solution. So we have if sine theta equals 5 over 13. We are asked to find cos theta. Now using this trig identity, we can see that sine squared theta plus cos squared theta is equal to 1. So we already have the value for what? Our sine what? Theta. So we have this to be what? Don't forget you have the square value. 5 over 13. 5 over 13 all square plus your cos squared theta is equal to 1. We are looking for the value of cos squared theta, right? So we are going to what? We are going to collect our like terms. But before that, we can what? Open this bracket. When we have 5 over 13 all square, that means 5 raised to power 2 and 13 raised to power 2. So 5 raised to power 2 gives us 25 and 13 raised to power 2 gives us 169 plus our cos squared theta is equal to 1. So let's call our like terms. We'll have this to be cos squared theta is equal to 1. If this crosses over, it becomes minus 25 over 169. Now, we are going to continue solving from this other side. So don't forget this continuation of question 1. We have cos squared theta. Let's rewrite. Is equal to 1 minus 25 over 169. So this is same thing as, now we want to subtract. Cos squared theta is equal to 1 over 1 minus 25 over 169. So we want to subtract fraction. We look for the LCM of the denominator. The LCM of the denominator is 169, 1 and 169. 169 divided by 1 gives us 169. Multiplied by 1, so here we still have 169. The minus sign, then we have 169 divided by 169 gives us 1. 1 times 25 gives us 25. So at this point, we have that cos squared theta is equal to 169 minus 25. That gives us 144. We have 144 over 169. Don't forget, we are looking for the value of cos theta, not cos squared theta. So in order for you to ascertain the value of cos theta, you are going to take the square root of both sides. So take the square root of both sides, it's going to cancel out this square here. So we have cos theta is equal to, take the square root of 114 and also square root of 169. So our cos theta gives us, square root of 144 gives us 12, and that of 169 gives us 13. So using this, our trig identity, sin squared theta plus cos squared theta, right, we've ascertained that this gives us what? 12 over 13. Now we have our second question, which I will allow you to attempt and give me your answer in the comment section, rather. So we have, if tan theta is 3 over 4, find sin theta plus cos theta. All you have to do, you have to work in a right angle triangle. Don't forget that your tan, which is opposite over adjacent. You do the placement, the first value, which is your opposite, 3, and then your 4 is your adjacent. All you have to do is to find the value of your hypotenuse. And don't forget, in order for you to get your hypotenuse is simply your opposite square plus your adjacent square. That gives you your hypotenuse, and then you can then add the values of sin theta and cos theta, and that gives you your final answer. We've come to the end of this video. Hope you love this video. Ensure you like, share, and subscribe. Thank you.